phlogiston, the remnant of the medieval worldview. And he'd pioneered a scientific method and so could make rapid progress in mapping the elements. But to Priestley's anger, Lavoisier claimed he had discovered oxygen because he recognized it as a new element. Trying to resolve who should get the glory proved to be a messy business. An embittered war of words and reputations broke out between England and France. Priestley was enraged that Lavoisier had tried to steal his thunder, and he had a point, because Lavoisier's experiments on oxygen weren't completed until after he'd met Priestley. Lavoisier may not have discovered oxygen, but he had recognized its significance. And it is Lavoisier, not Priestley, who's known as the father of chemistry. The discovery of oxygen had finally crushed any vestiges of the Greek concept of the four elements. Water was made of hydrogen and oxygen. Earth and air were a whole hodgepodge of different elements. And fire, well, that wasn't an element at all. Chemistry was being hauled into the modern era. It was an age when chemists were splitting matter, making great discoveries, just trying to understand what our world was made of. But there still didn't seem to be any order, any logic to their findings, just random elements dotted around the chemical landscape. Lavoisier was the first scientist to define what an element was, a substance that could not be decomposed by existing chemical means.
This is the manuscript.
And he set about drawing up a definitive list of all the elements. Now 33 replaced the ancient 4. So this is it. This is Lavoisier's original list of elements. It's in French and it's in his handwriting, but I can still sort of pick out what it says. He's divided them up into 4 groups, 4 categories of elements. There's the gases, the non-metals, metals and earths. You can see among the gases he's got oxygen and hydrogen. He didn't get it all right. I see he lists here arsenic and antimony among his metals. Today they're not considered to be metals. But even more fascinating, he has lumière, or light, and calorique, heat, listed among his elements in the gases. Of course, light and heat we know now to be just pure energy. But these mistakes apart, this was a huge leap forward in chemistry. It was an early realization that perhaps there was some order to the elements, some grand pattern to the building blocks of our world. And Lavoisier didn't stop there. He created a system to classify the discoveries of many other chemists and set out to transform the language of chemistry. He began a revolution of scientific vocabulary, replacing the picturesque and poetic with precision. So dephlogisticated air became oxygen. Astringent Mars saffron became iron oxide. Oil of vitriol became sulfuric acid, and philosophical wool became zinc oxide. At last, there was a universal language to identify the elements. Maybe it's a shame that some of these exotic names have been replaced, but in a way, I admire Lavoisier's logic. He revolutionized chemistry, but other revolutions were in the air. In 1789, the French Revolution would have terrible consequences for both Lavoisier and his rival Priestley. In England, Priestley's sympathies for the uprising gained him unwelcome attention. Things came to a head in 1791 when an angry mob, frightened that revolution would find its way to England, descended on his new home and burnt it to the ground. Thanks to a tip-off, Priestley escaped unharmed. but decided to flee to America. Lavoisier was not so lucky. Despised for his government work, Lavoisier and 28 other tax collectors were tried and found guilty of conspiring against the people of France. He was brought here to La Place de la Révolution that same day, May the 8th, 1794, and in 35 minutes they were all executed. The next day, the French mathematician Joseph Lagrange commented, "It took them just an instant to cut off that head, but another 100 years may pass before another like it is seen." Lavoisier left an incredible legacy. He'd cast out old dogma and replaced it with an empirical approach. There was no going back. Experimentation could now prove or disprove the most radical of ideas. But scientists were still convinced that more elements must be out there and were desperate to find new ways of revealing them. Matter remained fundamentally impenetrable, and it would take a powerful and dangerous force to find a new way of splitting it apart.